Our planet's story is a story of climate. It has never been static. In the beginning, Earth was a hellish landscape. Volcanoes dominated the skyline. They spewed carbon dioxide and other gases into the primordial atmosphere. This created a powerful greenhouse effect. It trapped the sun's heat. It kept the young Earth from freezing solid. This was the first natural climate change, a delicate balance between a fiery core and a cooling crust. For billions of years, the climate was unstable. Then, life appeared. Tiny organisms in the oceans began to do something extraordinary. They performed photosynthesis. They consumed carbon dioxide from the atmosphere. They released oxygen as a waste product. This was a planetary revolution, the Great Oxidation Event. The levels of greenhouse gases dropped dramatically. The planet cooled. Earth experienced its first ice ages, so severe they may have frozen the entire planet in a snowball Earth. Life itself had changed the global climate, setting the stage for more complex organisms. Millions of years passed. The Carboniferous period. Lush, swampy forests covered the land. When these giant plants and trees died, they did not fully decompose. They were buried, crushed by immense pressure and heat over millennia. This organic matter transformed. It became the coal, oil, and natural gas we use today. This process safely locked away or sequestered billions of tons of carbon deep underground. It helped maintain a stable and temperate climate for the age of the dinosaurs. This stored carbon was the planet's ancient battery, and we were about to plug it in. Even in more recent times, the climate has had natural cycles. Ice ages have come and gone. These were driven by subtle shifts in Earth's orbit and tilt. These are called Milankovitch cycles. They altered how sunlight reached the planet. These changes were slow. They happened over thousands of years. Ecosystems had time to adapt, to migrate, to evolve. Meanwhile, carbon dioxide levels naturally fluctuated between about 180 and 280 parts per million, a stable range for human civilization to emerge. Then, everything changed in an instant, geologically speaking. The Industrial Revolution began. Humanity learned to dig up and burn those ancient fuels. Coal first, then oil and gas. We unlocked the stored carbon from millions of years in just a few centuries. We began pouring unprecedented amounts of carbon dioxide into the atmosphere. The planet's natural balance was being overwhelmed. This was the Great Acceleration, the start of the Anthropocene, the age of human influence. Scientists began to understand the consequences. In the 1950s, a scientist named Charles Keeling began meticulous measurements at Mauna Loa Observatory. He tracked a steady, alarming rise in CO2, year after year. The line on the graph climbed, creating the famous Keeling curve. It was the heartbeat of a warming planet. The greenhouse effect, once essential for life, was now being supercharged by human activity. We had become a force of nature, rivaling the volcanoes of the past. By the 1980s, the scientific consensus was growing. Computer models, first developed decades prior, were now showing clear and alarming trends. Warnings were issued to world leaders. The evidence became undeniable. The 1990s and 2000s saw rising public awareness and the first major international agreements like the Kyoto Protocol. Yet, global emissions continued to rise. The debate shifted from if it was happening to what we should do about it, a conversation fraught with economic and political challenges. Now, We are living the consequences. The signals are all around us, and they are intensifying. More intense and frequent wildfires, consuming forests and communities. Stronger, more destructive hurricanes, fueled by warmer ocean waters. Rising sea levels from the relentless melting of ice in Greenland and Antarctica. Protracted mega-droughts threatening food supplies and freshwater resources. This is no longer a future threat. This is the current reality of a changed climate. We are now seeing the impacts of the carbon we emitted decades ago. So where do we go from here? The future is not yet written. We have the solutions. Renewable energy is now cheaper than fossil fuels in many parts of the world. Technologies for carbon capture and energy storage are advancing rapidly. The choice is now a matter of political will, economic investment, and global cooperation. We can choose a path of rapid decarbonization, adaptation, and innovation. Or we can face escalating costs, crises, and irreversible tipping points. The difference between these futures is a matter of degrees, literally. The history of Earth's climate is a saga of slow, natural cycles, punctuated by the rapid rise of one species. A species that learned to harness ancient sunlight, and in doing so, altered the planet's future. We have taken a 4.5 billion-year-old story and, in a mere 200 years, written one of its most dramatic chapters. The next chapter is ours to write. Will it be one of warning, studied by whatever comes after us, or one of wisdom, where we stabilized the system we disrupted? The data is clear. The choice is ours.
Inflatable.